AP Cram, Calculus AB, Free Response Exam Review, Question 54, Difference Quotient, Approximate the first derivative. Alright, so hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in that cup at time t on the closed interval t is either greater than or equivalent to 0 minutes or less than or equal to 6 minutes. When I say closed interval, I mean they include the endpoints 0 and 6 as pictured here. Is given by the differentiable function c, where t is measured in minutes. Selected values of this differentiable function c of t, measured in ounces, are given in the table above. Okay, so here are the selected values in units of 1 from 0 to 6 minutes. Use the data in the table to approximate C prime, that's the first derivative of 3.5 minutes. Show the computations that lead to your answer and indicate units of measure. So this is pretty straightforward, but the solution might not be so obvious. And if it's not, that's totally fine. But I'll give you a moment to think. All right, so we're tasked with finding C prime of 3.5 minutes. And what we have to do is to construct a difference quotient using the time and ounce data values across the smallest time interval containing 3.5 that is supported by the table, and that would be 3 and 4 because 3.5 falls between 3 minutes and 4 minutes. Okay, and then what you have to try to realize is that the derivative is the rate at which the amount of coffee in the cup is decreasing. So the rise over the run, x values in the derivative, y values in the numerator. And if you technically x and y is incorrect, so I'm going to say the output values over the input values, okay? And this kind of sounds like a slope. It's just, a change across a certain interval. And again, in this instance, it's the rate at which the amount of coffee in the cup is increasing in ounces per minute. So ultimately, our units of measure are going to be in ounces per minute. So let me just give you a visual of everything that I'm trying to say because it sounds like a jumbled mess right now. So basically, we're taking a difference quotient, C of 4, which would be 12.8 ounces, minus C of 3, which would be 11.2 ounces, over their corresponding values in minutes, so 4 minutes minus 3 minutes. And that is equivalent to, again, 12.8 ounces minus 11.2 ounces. And if we simplify the denominator, we get 1 minute, which further simplifies to 1.6 fluid ounces represented as OZ per minute. Okay? Yeah, fluid ounces are OZs. There's like a weight ounce. That's like, I don't know the notation for that, but can someone let me know? All right. I know I kept on babbling, but that's pretty much it.